In this video, I will explain you how to derive and get an equation for displacement current. Okay, now we have a capacitor and the reason for displacement current is the change in electric field here. And how does the electric field is changing? Now initially, let's say when we are charging the capacitor, one Q more Q comes. See, the charges are getting accumulated one after other and to become a total charge of Q, and at that position I can say that it is fully charged. Now, what is the electric field in between two capacitive plate? We know that sigma by epsilon 0 is the electric field. Now I will tell you how to derive the value. How to get the value of sigma by epsilon 0. See, due to an infinitely long charged sheet, the value is sigma by 2 epsilon 0 on both the ends. Sigma by 2 epsilon 0. Here, at this point also, this will be giving an electric field which is sigma by 2 epsilon 0. Now this is, in the case of capacitor, this will be positive and this will be negative. And this will also be giving electric field across here and here. What is the value? Sigma by 2 epsilon 0 and sigma by 2 epsilon 0, sigma by 2 epsilon 0. Now here you see at this side of the capacitor, the electric field, sorry, this is negative charge, right? So this will be towards it, and here also it will be towards it. Now here sigma by 2 epsilon 0 and sigma by 2 epsilon 0 equal and opposite, they cancel, and in between sigma by 2 epsilon 0 and sigma by 2 epsilon 0, they add up. So what will be the value? Same value plus same value, that will be twice the same value, sigma by 2 epsilon 0. So 2 will cancel and net electric field is sigma by epsilon 0. That is what I have given here. Now here positive is giving in this way, negative is giving sigma by 2 epsilon 0 in this direction, equal and opposite, net cancel. So we have only electric field in between two capacitive plate, and that is sigma by epsilon 0. So electric field in between two parallel plate capacitor is equal to sigma by epsilon 0. Now sigma, we know what is sigma? Charge per unit area divided by epsilon 0. Sigma is nothing but surface charge density. So this is Q divided by A epsilon 0. So electric field is equal to this. Now get the value of Q. Q is equal to electric field into area into epsilon 0. Yeah, epsilon 0. So epsilon 0 A into electric field. Now what are the parameters changing here? Q on this is changing, right? Charges are being added to here, one electron after other. So here it is positive charges added here, and finally that is getting fully charged. Anyway, with respect to time, charge is changing here and even electric field is changing. Whenever charge changes, electric field also will change. Okay, now find the time rate of change of this equation. So dq by dt is equal to, why dq by dt? Because q changes with respect to time. Epsilon 0 and A will come out. That is a constant, right? Area of the plate is constant and even epsilon 0 is constant. This is equal to dE by dt. Because electric field is changing with respect to time. Now what is dq by dt? See, change in dq by dt means time rate of change of charge, but actually there are not transfer of charges in between two plates. That is not there, but there is a quantity which is similar to time rate of change of charge. So this can be written as ID because it is having the same dimension and even unit of the one IC is equal to dq by dt. But dq by dt is nothing but charges passing through a point, but here dq by dt is nothing but charges added in 1 second. Okay, displacement current is equal to epsilon 0 A dE by dt. Now if you are taking A to this side, epsilon 0 dE by dt into A, we know that area in the electric field is flux, so epsilon 0 into d phi by dt, but this will be d phi e. So either you can use this equation or you can use this equation. This is very important. Okay, thank you.